Hello, dear students. Good evening. Today we are going to start our first session on three-dimensional geometry, and we will continue with several sessions to complete this particular unit. Now, before I proceed further, could you please confirm that you are able to view the screen properly and able to hear my voice very clearly?
Yes.
Okay, great, great. So, in this chapter, what we are going to study? We are going to study first the direction cosine and direction ratio of a line joining 2 points. Okay. So first we will understand, what is a direction cosine, and from there we will understand what is direction ratio. In the previous, class, in the vector algebra, there we discussed about direction, line, direction, angle. So it is a kind of a, you can think of extension of this. Then we will discuss the equation of line and planes in space, that is in three-dimensional geometry, under different conditions. Okay, so that is the second one. First one I already said. Then third one, we will discuss the angle between two lines, angle between two planes, and the angle between a line and a plane. So there are three types of angles we will be discussing. The first one is that angle between two lines. Then we will discuss angle between two planes. Then we will discuss the angle between a line and a plane. Okay. Then we will discuss the shortest distance between two skew lines. Okay, skew lines maybe you are hearing for the first time. So skew lines are, I can tell you in brief and later we will discuss in details. Skew lines are lines which are non-parallel and non-intersecting. You may be little surprised, sir, how come it is possible that two lines are not parallel and not intersecting? It is possible in 3 dimension, okay, or higher dimension, any dimension above 2 dimension. For example, if I can show you with a example. So suppose we construct a cuboid, for example. So this is a cuboid. Now you see it is it is a three-dimensional shape, right? Now in this one, if I keep a straight line something like this, which is in the green color, and another straight line in the blue color, I keep like this. So if you can think of this cuboid as a kind of a house or a room, then the green line is kept into the ceiling and the blue line kept into the floor. Now you see these two lines, the green line and the blue line, they are not intersecting because they are in two different planes and they are not parallel as well. So these lines are called skew lines. We will discuss in details when we discuss the shortest distance between two skew lines. Okay. Then we will discuss, dear students, the distance of a point from a plane. Okay. Now, what about the topics I have mentioned here? All this will be discussed in a all the results. Result mean direction. Equations of lines and in plane. Equation of lines and planes in space under different conditions, angle between two lines, two planes, a line and a plane, shortest distance between two skew lines, and the distance of a point from a plane. All results will be first obtained in the vector form. Now to make these things well understood, from a clear geometric point of view, and as well as to get a proper analytical picture. So we will translate those results obtained in the vector form in the Cartesian form as well. In simple terms, what I can say is that whatever the results we will be obtaining, first we will obtain into the vector form, and then we will make it into the Cartesian form, so that in both the forms you will able to get that result. And in the exam also there will be questions to be asked to give the answer either in the vector form or in the Cartesian form. Or the other way I can say is that the questions what will be given, maybe the questions given in the vector form, then the result you need to provide in the vector form, or the questions given in the Cartesian form and you need to give into the Cartesian form. Sometime it may be asked the questions given in the vector form, the result has been asked in the Cartesian form. That also you can do if you know the relationship between the vector form and the Cartesian form with respect to the topics what we are going to discuss. Okay. So with all this points set up, the entire series of lectures will be completed in several sessions. I also do not know exactly today that how many sessions it will need, but it will need at least 5 to 6 sessions. Okay. And that also depends on that what pace we are actually discussing. Now let's start for the first one as a direction cosine and direction ratio of a line. Okay. So in the previous unit, when we discussed about the vector algebra, there you had a clear understanding about the direction angle. Okay. So if we have a directed line L passing through the origin, makes an angle alpha, beta, gamma with the x, y and z axis respectively, these are called the direction angle that we discussed during the vector algebra discussion. Now cosine of these angles, that is cos alpha, cos beta, cos gamma, they are known as the direction cosine. That is why it is called direction cosine. I repeat once more. Suppose there is a directed line. What is directed line? That also I can say in brief is that a line which has a proper direction. Okay, because if I construct a line, the direction either could be in this direction or it could be in this direction. Okay, so if any one direction we are considering, that is called the directed line. So this is a directed line L passing through the origin. Okay, now passing through the origin, after some time we will discuss that if a straight line is not passing through the origin, then how we can find the direction cosine and direction ratio, that we will discuss after some time, after a few minutes. Now let's assume for the time being there is a directed line passing through the origin and makes angle alpha, beta and gamma with x, y and z axis respectively. Okay. So now these angles alpha, beta, gamma are known as the direction angle. You are already aware of it. Now cosine of these angles are known as the direction cosine. That means in simple terms, if there is a directed line L passing through the origin, makes an angle alpha, beta, gamma with the x, y and z axis respectively, then you can say cos alpha, cos beta, cos gamma are the direction cosine of that directed line L. Now as I was telling a minute back that a line can have two directions, that means if we reverse the direction of L, then the direction angle are replaced by their supplements. That means if alpha is an angle, its supplement will be pi minus alpha, then pi minus beta accordingly and pi minus gamma. So suppose if I say from suppose this is a point A and this is L, if AL is making an angle alpha, beta, gamma with x, y, z axis respectively, then AL dash, where we have actually reversed the direction of L, AL dash will make an angle pi minus alpha, pi minus beta, pi minus gamma respectively with the x, y and z axis. So, we will see the sign of these directions cosines we will change, because we know the value of cos alpha and value of cos pi minus alpha is actually negative, right? Means cos, what I wanted to say is that cos of pi minus alpha is equal to minus cos alpha. Okay, so for example, if we get direction cosine as LMN, that is the way it is actually denoted, this is the convention, then if we reverse the direction of that line, so that reversed line direction cosine will be minus L minus n minus n. Okay, and we will discuss all these things in details after some time. So now let me place this image and then discuss further. Okay, at any point of time, if something is not clear, please stop me, get your understanding clear, and then we will proceed. Okay, so you think about this line OL. Okay, that before that I can tell you, as you see that OX, OY, OZ are the three coordinate axes in the in a three-dimensional geometry. You are already aware of it, and we are having a directed line OL. You see, this is the directed line OL. Okay, now a given line in space can be extended into the two opposite directions, as I was telling that OL, then you can extend into the opposite direction. Then in order to have a unique set of direction cosine for a given line in space, we must take a given line as a directed line. For example, in this case we are considering is OL, and what are the directions cosines are denoted by? As I was telling a minute back, it is L, M, N. Okay, so this is the convention. When you say the L, M, N in context to the three-dimensional geometry, it is actually the directions cosines of a particular line. Okay, now let me proceed further. Let me see whether it can be kept it here or not. Let me keep it here. Yeah, I need to reduce this thing a little bit. You are able to view the content, right? Whatever I just placed, is it visible?
Yes, sir.
Okay, great. So now I told you a few minutes back that how to find the direction cosines of a line if that line is not passing through the origin. So far we discussed what? So far we assumed that line is passing through the origin. In this case, as you see, OL is actually passing to the origin, where O is the origin. But what will happen if a line is not passing through the origin? So in that case, what we will do? We will draw a line parallel to that line which is not passing through the origin, and that line which is passing through the which is parallel to the given line must pass to the origin. Let me show you here. For example, let me draw the line in a green color. Suppose this is a line, its direction cosine we are going to find, for example. But so far we discussed what? Direction cosine of a line to find the direction cosine of a line, that line has to pass to the origin. But as you see, the green line is not passing to the origin. Now how to find the direction cosine of that line? So for that, what we will do, we will draw a line parallel to this green line, but it is passing to the origin. That means it is a line something like this. Please excuse me in case you see my drawing is not exactly up to the, but here it looks like fine, right? The green line and the blue line are parallel to each other. Now what we will do, we will find the direction cosines of the blue line, and that will going to be the direction cosines of the green line. Why? Because if the blue line makes an angle alpha, beta, gamma with the x, y and z axis respectively, then the green line is also make the same angle alpha, beta, gamma with the x, y and z axis, because both these lines are parallel. So this is the way we are going to find, and that is actually mentioned in the remark section here, as you see. So let me read it out. So if the given line in space does not pass to the origin, if the given line in space does not pass to the origin, then in order to find its direction cosines, we draw a line through the origin and parallel to the given line. You see, I repeat once more, if the given line in space does not pass to the origin, which is the green line, then in order to find its direction cosine, we draw a line through the origin and parallel to the given line, that is the blue line, that is a parallel to the green line. Now take one of the directed lines, in this case the green line, sorry, in this case the blue line. Now take one of the directed lines from the origin and find its direction cosines. That means what? That means we will find the direction cosine of this line. Okay, and as these two lines are parallel, it is going to be the same direction cosines will be applicable to the green line, and it is actually mentioned here that as two parallel lines have same set of direction cosines. Now we got an idea about direction cosines. Okay, that what are direction cosines? I can tell you in brief. If a directed line makes an angle alpha, beta, gamma with the positive direction of the x, y and z axis respectively, then cos alpha, cos beta, cos gamma are called the direction cosines. That is the definition. Now if any three numbers which are proportional to this direction cosines of a line are called the direction ratios. What is that? So if L, M, N are the direction cosines of a line and ABC are the direction ratios, then definitely that L, M, N and ABC will be proportional. That means what we can say, A should be equal to lambda into L, B should be equal to lambda into M, and C should be equal to lambda into N, where lambda is a real number. So what I can say, dear students, is that suppose a line is having direction cosines. So I am writing direction cosines as DCs. What are the direction cosines? Direction cosines are L, M, N. Now if the same line's direction ratios are A, B, C, then L by A should be equal to M by B should be equal to N by C. Now in this case, whatever I mentioned here a minute back, A equal to lambda into L, B equal to lambda into M, and C equal to lambda into N. You know, in some books it is also mentioned the direction ratios as direction numbers. So it is very rare that you get a question where you will get direction, the question has been asked as direction numbers, but in case you please assume this as direction ratios. So direction ratios and direction numbers are same. Now, keeping in mind that L, M, N and A, B, C are proportional, okay, suppose direction ratios of a line is given and we are going to find the direction cosine. So that means what? Let ABC be the direction ratios and it is given. ABC are given. And what we are going to find? We are going to find LMN, that is the direction cosines of this line. Okay, so if ABC are the direction ratios of a line and LMN are the direction cosines of the same line, okay, then we are going to find the values of L, M and N in terms of A, B and C. So what I am saying, whatever I said so far, if I can tell you in brief, that A, B, C, that is the direction ratios, these are given. I gave the right sign, that means it is given. Now what we are going to find? L, M, N we need to find, question mark, and that L, M, N we need to find in terms of A, B, C, because A, B, C is known to us. How to find? Now one thing we are aware of, that L by A equal to M by B equal to N by C, as I explained here. So we can assume that L by A equal to M by B equal to N by C is equal to K, where K is a constant, a real constant. So from there what we will get? L equal to A into K, M equal to B into K, and C is N, sorry, L equal to A into K, M equal to B into K, and N equal to C into K. Now L square plus M square plus N square equal to 1, that is a very important relationship, and I will explain after some time. I will explain the proof that how come L square plus M square plus N square equal to 1. I will prove it. Okay, but let's assume for the time being that L square plus M square plus N square equal to 1. Then what we will get? That K square into A square plus B square plus C square equal to 1. And from there we get the value of K as plus minus 1 by square root of A square plus B square plus C square. So then we can easily find the value of L, M and N in terms of ABC, and let me show you here, just a minute. Okay, let me first place the note and then I will explain. So dear students, so from this value of K equal to plus minus 1 by square root of A square plus B square plus C square, and that we are applying here. We get the value of L, we get the value of M, we get the value of N, correct? Plus minus. So we see what? We are able to express L, M, N in terms of ABC. Now you see it is plus minus. So here, so we need to take either the plus together or minus together. We must not mix the plus and minus. That means if you take L as plus, then M and N has to be taken the plus. If you take L as minus, then M and N has to taken as minus. So depending on the desired sign of K, I repeat, depending on the desired sign of K, either a positive or a negative, means you can take either positive sign or negative sign to be taken for L, M, N. Correct? I hope it is well understood. Now, yes. Okay, great. Now, L, M, N is direction cosines. Direction cosines are always unique for a given directed line, but direction ratios can be many. In fact, it is infinite. Why? Because direction ratios and direction cosines are proportional. Only one restriction is there on direction. Suppose let me write it here. Suppose direction cosines are what? Direction cosines we are writing L m n. Then what is the condition? L square plus m square plus n square is equal to 1. That condition has to meet. Then only we can say that L m n are the direction cosines of a line. But for direction ratios, there is no such restrictions. Only one condition has to be satisfied. Suppose if we can say the direction ratios are A, B, C, then all we need to say is that L should be equal to lambda into A, M should be equal to lambda into B, and N should be equal to lambda into C. That's it. Now you vary the value of lambda, or the other way you can say that A equal to 1 by lambda into L. So let me write this thing. So from here we can write A equal to 1 by lambda into L, B is equal to 1 by lambda into M, and C is equal to 1 by lambda into N, where lambda is any real number except 0. Now you change the value of lambda, you will get different values of A, B, C. But the value of LMN is unique for a directed line. But for that same directed line, the value of ABC can be different. And this is actually explained in slightly different manner in this one. What is that? For any line, I read it out and explain. For any line, if A, B, C are direction ratios of a line, then Ka, Kb, Kc, where k is not equal to 0, is also a set of direction ratios. So any two set of direction ratios of a line are also proportional. Obviously, if ABC is a direction ratios, then K, Kb, Kc, they are also the direction ratios of the same line. So you see ABC and Ka, Kb, Kc are proportional. Okay. Also, what we can say, for any lines there are infinitely many sets of direction ratios. And to make the statement absolute complete, what I can say, that the direction cosines has to be unique, that is L, M, N. Now as we understood about that direction ratios and direction cosines, now let me proceed to the next one to prove that L square plus M square plus N square equal to 1. As I said few minutes back, that let's assume that L square plus M square plus N square equal to 1. Now let me prove that how L square plus M square plus N square equal to 1. Okay. So dear students, as you see, let me place this statement very well. Okay. Now let us consider RS be the line. Okay, RS be the line. As you see, the line RS is not passing through the origin, and let's assume that its direction cosines are L, M and N. Let's assume. Okay, and we are going to find a relationship. That relationship I already disclosed few minutes back, that is L square plus M square plus N square equal to 1, and we are going to derive that, we are going to prove it. Okay, so let's consider that RS be the line, okay, having the direction cosines L, M, N. Now through the origin, so in order to find the direction cosines of that line RS, what we need to do, dear students, we need to draw a line parallel to RS and passing through the origin, and let us consider OP be that line. Okay, that OP is the line which is parallel to RS, but OP is passing to the origin O, as you see it here. Okay, and let us consider any arbitrary point P on that line OP. In fact, that P is that point having coordinates x, y, z. From the point P, we draw a perpendicular PA on the x-axis. So that means what? This angle is actually 90 degree. Though it doesn't looks like, but if you think in the three-dimensional point of view, you will find this angle, that angle OAP is actually 90 degree. How come? Because the point P is in the space 3 dimension, and from that point P you are drawing a perpendicular on the x-axis, and A is the foot of that perpendicular, the point A. So definitely that PA and OA will be perpendicular to each other. That's why this is a perpendicular, and that actually been shown here in a little elaborated manner. You see, from the point P we draw a perpendicular. So let's consider this is the x-axis actually. Okay, so this is the x-axis. From the point P we draw a perpendicular to the x-axis, and A be the foot of the perpendicular, and as I was telling that PA and OA are perpendicular. Now you are able to get it that PA and OA are perpendicular, and let us assume that OP is R. Okay, let's assume OP is equal to R. Then obviously that line OP makes an angle alpha with the x-axis. So what we can find cos alpha? It is base by hypotenuse, that is OA by OP. As you see it here, OA is nothing but x, because if the point P is having the coordinates x comma y comma z, then the point A is having coordinates x comma 0 comma 0, because the point A is on the x-axis, and in which the A be the foot of the perpendicular drawn from the point P to the x-axis. So obviously that OA should be x, so OA is x and OP is R. So we get cos alpha equal to x by R, or we can say that x equal to R cos alpha, and we know cos alpha is nothing but L, so x equal to L into R. We know now that L is equal to cos alpha. LA mean are the direction cosines, so that means obviously L is equal to cos alpha, M is equal to cos beta, and N is equal to cos gamma. So in the similar manner, as we have able to achieve that x equal to L into R, in the similar manner we will be able to achieve y equal to M into R, and z is equal to N into R. Correct? We are in same manner we are able to achieve this thing. So now if we square the left hand side and add, that means x square plus y square plus z square, that should be equal to R square into L square plus M square plus N square, obviously. Now what is x square plus y square plus z square? That is nothing but R square. I hope you understand this thing, or if you do not understand, then I can quickly give you a proof. Okay, so let me use a different color. Let me use the color green color. Let me take. Okay, so how we can prove that R square equal to x square plus y square plus z square? So let me draw a perpendicular. So when we say the point P is having coordinates x comma y comma z, that means what? That means this is x, OA equal to x. Okay, so this OA equal to x. Then from that point A we will draw a line parallel to the y-axis and come to this point. Suppose you came to the point B, then AB should be y, and after that from the point B parallel to the z-axis we will reach to the point P, correct, and that BP will be actually z, correct. Now what we can do, dear students, is that first we can draw this line OB. What will be the OB? OB will be equal to x square. OB will be equal to square root of x square plus y square, because OAB is a right angle triangle, because this is right angle. So we can say that OB square is equal to x square plus y square, Pythagoras theorem. Now again, if you see that OBP, that is also a right angle triangle, correct, in which this is right angle, correct. So what we can say, OP square equal to OB square plus BP square. So what I say is that OP square is equal to OB square plus BP square, same Pythagoras theorem. So OP square is what? Our assumption OP is equal to R, so OP square equal to R square. So we get R square equal to OB square. OB square we just found out as x square plus y square, and BP square is nothing but z square. BP is equal to z, so BP square equal to z square. So we are able to achieve that x square plus y square plus z square equal to R square. So now if we apply that, we will get the relationship L square plus M square plus N square equal to 1. This is very important relationship, dear students. Every year in the board examination question comes, and also in entrance examination you need to apply this formula to solve relevant problems. I hope it is very clear that how to derive the relation between the direction cosines of a line. Now let's proceed further. Okay, so the next point what I am going to discuss is that the direction cosine of a line passing through 2 points. Okay, very important. This is also, these are the building blocks on which we are going to discuss the other portions of three-dimensional geometry. So that is why I am explaining by taking time, and you can also, as it is getting recorded, you can watch it multiple times to have an absolute clear. Fundamentally, the difficulty about three-dimensional geometry is that we explain something in the two-dimensional coordinate system, means in a two-dimensional plane. Whatever I am explaining in this digital board, right? Hopefully I should make a video of it where I am explaining in front of the camera and with a three-dimensional object. That I will do in later, but due to time, I do not have much time, very busy. That is why I am making this thing. If something is not clear, please let me know, and I will make a video of which will be more understandable. Now let's come back to the point. So direction cosines of a line passing through 2 points. So let us consider 2 points. One point is point P and the another point is point Q. Okay, point P and point Q. And point P is having the coordinates x1, y1, z1, and the point Q is having coordinates x2, y2, z2. Correct? Clear? Not a big deal. Now what we are doing, what is our objective? Our objective is to find the direction cosines of the line PQ. And what is given to us? All is given to us is the coordinates of the point P and coordinates of the point Q. So that means what? We need to derive the direction cosines of that line PQ in terms of the coordinates of the point P and Q, that is in terms of x1, y1, z1 and x2, y2, z2. That's it. Okay. Now how to derive that one? For that we need to do some construction. The first construction is that, dear students, that in the xy plane we are drawing two perpendiculars, one from the point P and another from the point Q. Now from the point P, if we draw a perpendicular to the xy plane, and let us assume R be the foot of the perpendicular, and from the point Q, if we draw a perpendicular to the xy plane, and let's assume S be the foot of the perpendicular. Fine. Then obviously PQ and RS are same of length, and after that what we are doing, we are drawing a perpendicular from the point P to the line QS. That means what? N is the foot of the perpendicular drawn from the point P to the line QS. That is, you see that PN is perpendicular to QS. Pn, I can write here, Pn is perpendicular to Qs, correct. Now what we are going to do, dear students, that whatever you see PQN here in the left hand side diagram is little small, so we have taken it in the little larger in the right hand side diagram, PQN, as you see it here. Now if we consider the line PQ makes an angle alpha, beta, gamma with the x, y and z axis respectively, then obviously that angle will be gamma. How come? Because this line, as you see, that if this line from the point P, it is a parallel to z axis, means I am talking about this line is parallel to z axis. Now if PQ has a the directed line PQ makes an angle gamma with the z axis, then definitely that same gamma is applicable with PQ and this directed line and this line which is parallel to this line which is parallel to z axis. Now this line, let's give a name to it. Suppose Pn, suppose I give this is as suppose S, PS. Okay. Now that PS is parallel to OZ. So as PQ makes an angle gamma with OZ, definitely PQ makes an angle gamma with PS also. Now PS and QN are parallel to each other, correct? Because we have already discussed that N is nothing but the perpendicular drawn from the point P to the QS. So obviously this angle should also be gamma, okay, because PS and QN are parallel and PQ is the transverse, correct? Go back to your fundamentals of mathematics of class 9, 10 standard and you will see this angle and this angle are equal. Okay. Now as these two angles are equal, what we can say, and now I can come to the next I can bring the next part and you will understand very well. Okay. So from here we will derive cos. Let me bring. Okay. Remember this diagram, and then because the next part is little lengthy, next part of the note. So I will go back to the previous screen as well. Okay. So what I wanted to say is that let's find cos gamma. Okay, let me find it here. What is cos gamma? Cos gamma. Okay, let me bring both this thing here. Yeah. So cos gamma is nothing but NQ by PQ. Cos gamma, if you look into this one, cos gamma is equal to base, that is NQ, by hypotenuse, that is PQ. So that is what is written here. Now written here means here. Now what is NQ? Look at NQ, this particular part, this NQ. NQ is nothing but the difference of the z coordinates of the point Q and point N. What is the coordinates of the point Q? The coordinates of the point Q is given as at x2, y2, z2. And what is the coordinates of the point N? It is actually x2, y2. Sorry, I'm so sorry. The coordinates of the point N, x and y coordinates of the point N will be same as that of the point P. So it is x1, y1, but its z coordinate will be changed. Okay, so that will be N. Actually, if I say that the point N's z coordinate will be different, that will be actually the z coordinates of the point P. Okay, its y coordinate will also get changed. It depends on how far it is actually being shifted, what is the what is the distance between them, but that is not the point of discussion here. All I can say is that z coordinate of the point n will be actually z1. Okay, I am not going to dilute this one, that x and y coordinate, let's not get confused, and also not required to discuss here. So our point is to find the value qn, that is nothing but the difference of z2 minus z1. That is, in simple terms you can write it is z2 minus z1 divided by pq, correct? So that is what is actually mentioned here, cos gamma equal to z2 minus z1 by pq. Got it? Now dear students, in the similar manner we can find that cos alpha as x2 minus x1 by pq and cos gamma as y2 minus y1 by pq. Now the direction cosine is what? Cos alpha, cos beta, cos gamma. So that is nothing but x2 minus x1 by pq, y2 minus y1 by pq, and z2 minus z1 by pq. But what is pq? pq is nothing but the distance between 2 points p and q, and as we know the coordinates of the point p and q, we can easily find the value of pq as square root of x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. So dear students, one important point here is that here we found the direction cosine of the line joining p and q. Now we know the direction cosine of a line means it has to be a directed line. So in this case the directed line is from p to q. Then this is the result, that is x2 minus x1 by pq, y2 minus y1 by pq, z2 minus z1 by pq. Means whenever we are considering the point p and q is here, if we consider the point p here and q here, let me write q properly, q here, and if this is the directed line, okay, and then this is the direction cosine. Now if we exactly reverse the direction, that means if we make from q to p, then the direction cosine will be x1 minus x2 by pq, y1 minus y2 by pq, z1 minus z2 by pq. Just I am informing, okay. So that you will get a very clear idea. Now we know the direction cosine and direction ratios are having a relation, is that they are proportional. So we see when we find the direction cosine, the denominator is pq always, correct, na? So that means what? That x2 minus x1 by pq, y2 minus y1 by pq, and z2 minus z1 by pq are proportional to x2 minus x1, y2 minus y1, z2 minus z1, correct? So what we can say? We can say the direction cosine as x2 minus x1, y2 minus y1, direction ratios, I am sorry, the direction ratios we can say x2 minus x1, y2 minus y1, z2 minus z1, or we can change the negative one, is that x1 minus x2, y1 minus y2, z1 minus z2, correct? Direction cosine ratios of the line segment joining p and q. When it is directed from p to q, it is x2 minus x1, y2 minus y1, z2 minus z1. When it is directed from q to p, it is x1 minus x2, y1 minus y2, z1 minus z2. I hope you got a very clear idea. Okay, now let's proceed to the next one. Okay, next one, there are a few examples. So let's quickly go through these examples. Let me make sure this is examples only, and all these are very small example, relevant examples, but you must follow the way I am explaining and make sure that you get it very clear. Okay. The question is very simple here, that if a line makes an angle 90 degree, 30 degree, 90 degree, 60 degree and 30 degree with the positive direction of x, y and z axis respectively, find its direction cosine. Very simple thing. We know if LMN be the direction cosines of that line, L is equal to cos of alpha. What is alpha? Alpha is 90 degree. What is beta? Beta is 60 degree. And what is gamma? Gamma is 30 degree. So L equal to cos alpha, that is cos 90. We know cos 90 is 0, so L is 0. M is equal to cos beta. Beta is 60 degree, so cos 60 is equal to 1 by 2. And N is equal to cos 30, gamma equal to 30, that is equal to root 3 by 2. So we get the direction cosines as, we can say 0, 1 by 2, root 3 by 2. I hope it is very clear. Now let's proceed to the next question. Next question, what is given, dear students? So let me first place it here and after that I will explain. So the question is that if a line has direction ratios 2, minus 1, minus 2, determine the direction cosines. So direction cosines, we know that direction ratios whatever will be there divided by square root of that a square plus b square plus c square. If you remember, if we consider a as 1, b as minus 1 and c as minus 2, then it will be ABC and divided by square root of a square plus b square plus c square, right? But one thing I can say here is that it could be either plus to get throughout, okay, or it will be minus throughout. That means I can take also minus. Both are applicable. So you can either say this entire thing, okay, or you can write plus minus. You can either take plus or you can take minus. Let me explain. If you take plus, it will be plus throughout. That means 2 by 3 minus 1 by 3 minus 2 by 3. And if you take minus, then it will be minus 2 by 3 but plus 1 by 3. Minus of minus 1 by 3 is plus 1 by 3 and 2 by 3, that is minus of minus 2 by 3 is 2 by 3. Got it? So this is the way we solve the second one. Now let's proceed to the third question and I am going to place it here. Okay. So here is the question. The question here is that find the direction cosine. Find the direction cosines of the line passing through the 2 points. We need to find the direction cosines of the line passing through the 2 points. Okay. So how to find it out, dear students? First we will find the direction ratios. Direction ratios is nothing but the difference of the corresponding coordinates. Okay, we know this thing, we have done this thing a few minutes back, the theoretical portion. Okay, so let me place this here and then let me explain. Okay, so first I describe the theoretical portion. We know the direction cosines of the line passing through 2 points P having coordinates x1, y1, z1 and Q having coordinates x2, y2, z2 are given by x2 minus x1 by pq, y2 minus y1 by pq, z2 minus z1 by pq, where pq is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. In our case, x1 is nothing but minus 2, y1 is 4, z1 is minus 5, x2 is 1, y2 is 2 and y3 is 3, z2 is 3. I repeat, x2 is 1, y2 is 2 and z2 is 3. We can find the value of pq as square root of 77 and we can find the direction cosines as x2 minus x1, that is 1 minus minus 2, that is 3, y2 minus y1 that is 2 minus 4, that is minus 2. Z2 minus Z1 is 3 minus minus 5 means 3 plus 5, that is 8. Direction cosines from the point P to Q, where P is the coordinates, P point having coordinates, I can write here is that minus 2, 4, minus 5, and Q is 1, 2, 3. Now if the line is direction cosine from Q to P, all will be negative, that is minus 3 by square root of 77 plus 2 by square root of 77 and minus 8 by square root of 77. Okay dear students, now let's proceed to the last question for today. Last two questions actually, together we will discuss. Okay. So dear students, so here we see find the direction cosines of x, y and z axis. First question. We know the x-axis makes an angle 0 degree with the x-axis, 90 degree with the y-axis and 90 degree with the z-axis. So obviously the direction cosines of x-axis will be cos 0, cos 90, cos 90, that is 1, 0, 0. In the similar manner we can find the direction cosines of y-axis as 0, 1, 0 and that of z-axis as 0, 0, 1. Done. Now the fifth example, that is a slightly different example. So question here is that so that the points A, B and C whose coordinates are given and as you are seeing in front of the screen are collinear. So how we are going to do? First we find the direction ratios of the point joining A and B, that you know the difference of the x coordinate, y coordinate and z coordinate, that becomes minus 1, minus 5, 7. So if I can explain you more elaborately, direction ratios of the line joining A to B is x coordinate of the point B, that is 1, minus x coordinates of the point A, that is 2. So 1 minus 2, that becomes minus 1. The another part of the direction ratios will be y coordinate of the point B, that is minus 2, minus y coordinate of the point A, that is minus 3, that is 3 actually, minus 2, minus 3, that is minus 5. And the third part of the direction ratio is that z coordinate of the point B, that is 3, minus z coordinate of the point A, that is minus 4, that is 3 minus minus 4, that is 3 plus 4, which is 7. In the similar manner we found the direction ratios of the line joining from B to C, and we get as 2, 10, minus 14. And we found the direction ratios of the line joining from A to B as minus 1, minus 5, minus 1, minus 5, 7. Now we observe that minus 1, minus 5, 7 and 2, 10, minus 14 are proportional. That means if you multiply by minus 2 of all the three components, that is minus 1, minus 5 and 7, we will get 2, 10 and minus 14. So that means what? The direction ratios, it is clear that the direction ratios of AB and BC are proportional. That means what? AB is parallel to BC. Now if we say AB is parallel to BC for both the lines AB and BC, B is a common point, right? B is a common to both AB and BC. So that means that ABC are collinear points. So that means what I wanted to say, if I can explain in the blue color. So suppose AB, we say this is the point A, this is the point B, and BC is also parallel. So obviously that BC will be something like this. Otherwise how come AB and BC can parallel? So that means A, B, C are collinear points. So with this note, let me conclude the session here. In the next class, we will start our next session on 3-dimensional geometry. In case any one of you have any question, please let me know. If everything is clear, then you can conclude. Please do let me know your comments, dear student. Do you have any questions?
No, sir.
Okay. Thank you.
No, sir.
All right. We will
Thank
meet
you,
in the
sir.
next class. Thank you.
Yeah.
Thank you, sir.